Hi, I'd like to do a tour through chapter 11. There's nothing all that new other than we have to use different tests, but we're still going to be doing the same kind of stuff we did in chapters 9 and 10. So we've got a confidence interval for two uh, proportions. We have confidence interval for the difference in two means. So that's for the confidence intervals. Then we also have a two-sample z-test for proportions and a two-sample t-test for means because we don't know the population standard deviation. So we have to use a t-test. We also have a t-test for paired data, and that's where we have like a before, after, or a comparison, two different approaches. Okay, so here we go with problem 1. Professor wondered if there's difference in proportion of students. Uh-oh, keyword proportion right there. All right, so professor randomly selected 20 math classes around campus, recorded the gender of individual and whether or not a student enrolled in the class at the beginning of the term dropped the class at some point during the term. Assuming all conditions satisfied, which of the following tests should the researcher use? All right, so we've got proportions, right? And we're looking at this two-sample z-test for proportions. All right, see if I can do a little better here. All right, next. All right, problem 2. Advertisement for diet program describes 70 obese adults. Each person in the study was weighed before beginning the diet and 5 weeks after starting the diet. Oh, wait a minute. That's pairing, right? Because each person is going to be tested twice, the testing being the weight. So they're going to see what they weigh before and after and see how each individual um, fared in this. Okay, so we want to do a 95% confidence interval for average weight change, and it went from -1 to 5 pounds. So it said, we could see as much as a 1 pound gain or as much as 5 pound loss. All right, so trying to decide if this diet works or not. Well, okay, we don't know the actual average weight change, do we? But on this interval, because it's both positive and negative, it says, ooh, all right, zero's in the interval, right? -1 to 5 includes 0. So there's no evidence to indicate the average weight loss is more than 0 for obese adults. Bummer. Okay, so, they cannot make that claim because it's not true on the average. All right, certain marathon. Okay, an interested fan wanted a difference in average winning times between the women's wheelchair winner and the men's running winner. 95% confidence interval. And notice it's going to be women's time minus men's time. So let's see, wait, if they're negative numbers, that means men had to have bigger numbers, right? Smaller minus bigger is negative. So that says, oh, wait, the women were faster and the men were slower. Okay, 95% confident, men's winning time. Oh, no, they weren't faster. Winning time, there we go. 95% confident, winning time between 2 minutes slower on average. Oh, okay. So if we are doing the winning time each year, so which of those is that going to be? Average winning time, 2 minutes faster, 95% of the time. No, that's the mistake there. It's like we're not saying 95% of the time they're faster. And faster. So, okay, so it's got to be one of these two. So are we sure that the winning time is faster each year? Well, no, what we're actually saying is when we take all of those and average them out. So I would say it's C. Okay. Whew. So now we've got a set of data. The nice thing about data is now we can look here and we've got each year and we've got the value on the 6th, Friday the 6th, and then Friday the 13th. Okay, so if we're doing this comparison, this is pairing. Again, each data set is paired to a specific month and year because things could change year to year and month to month. So we want to do paired. All right, so 2 sample z-test for proportions. Oh, no, those are not proportions. Wilcox and rank sum test. We're not even studying that, so no, that's not it. Paired t-test, sounds good. Chi-square test, no, we're not studying that either. 2 sample t-test. Well, no, because they are paired, we're going to say this is a paired t-test. Okay, next. Some students do homework with the TV on and they want to see if they can work effectively with distractions as without them. You know, hey, everybody claims they can study with the TV on or in this day and age, their phone. So let's see what happens here. We're going to each volunteer do a relatively easy crossword puzzle under one condition and then the other. And notice they're randomly assigned. Okay, so wait, we're going to see how each person does in the 2 places. So that would be a paired t-test. Again, if we just had one group that did the puzzles with the distraction and another group without, that would be a 2 sample t-test. But notice we're seeing how each individual does. So again, pairing, we're going to say, you know, let's see how each student does with and without the distraction. Uh-oh, here we actually have to talk about correct null hypothesis. I kind of jump ahead, you know, what are we looking for? What's the correct null hypothesis? Oh, wait, it's that marathon again. So remember that we're always doing the null hypothesis equal to 0. I don't care if we're doing paired or proportions or anything, it's going to be equal to 0. So can't be that one. Okay, equals 0, equals 0, equals 0. Okay, so A's out. It's got to be one of these. But we are looking at the average difference of all of the tests. You know, I'm sorry, all the races. They're going to say, okay, how did it go? So we're going to say, we're going to assume that the difference, mu of difference, we're going to say, let's average all of them out for the population. So we're going to say mu difference between women's winning time and men's running time. So that sounds pretty good to me. All right, so there we go. Let's go on to, all right, here's that certain marathon. Again, we're continuing. Oh, okay. Interested who is faster? Okay. Now, notice here that X bar is negative 10.9, negative number. So that says we're looking at the difference is less than 0. Okay, that's kind of a quick thing. You know, if that had been positive, then we would have said we're testing to see if it's a number greater than 0. So you kind of look right there and, oh boy, there we got our answer. All right, so now we're going to say a paired t-test. Oh, yay. Remember I said it was paired. Okay, so p-value 0.001 if the probability of an event happening is extremely small, that says we've got sufficient evidence to reject the null hypothesis. All right, so we're going to say there is sufficient evidence to indicate the men's winning time and time each year are different on the average. All right. So, yeah. See, I always read the other ones just to make sure I'm not missing something. Because it's paired, that's why it's not E. We're going to say we're going to find the differences and then average those differences. So yeah, I'm going to go with D. Oh boy, this is a tough one. I've got to do them fast, fast, fast. All right, many drivers say they, on regular versus premium and want to see which is better. So, okay, 10 cars, randomly selected, all cars are regular. Each was filled with either regular or premium first, decide by coin toss, mileage for that difference. Okay, ooh, we are doing paired again. Each car is run both with and without. All right, ooh, there's that p-value again. Tiny number, so it means we're going to reject the null hypothesis. There is sufficient evidence. Okay, so B and C are out, right? We already know, no, this is very, very unlikely to have occurred if the null were correct. So, are we going to say sufficient evidence, premium is better than regular? Okay, premium minus regular, and we get a positive number. Ooh, yeah, this one says 0. Ooh, no, that's the null hypothesis saying there's no difference. So we're going to say it's actually A. Oh, last one. Okay, Elmo likes music. Oh, Elmo. Oh, sorry. He wondered if listening to music while studying will improve scores on an exam. 50 students are told. Take midterm, agreed to be part of the study. Half were randomly assigned to listen to classical music while studying. The other half were told not to listen to music while studying. Okay. Wait a minute. That's two different groups. We're not having them do it both ways. So we've got these values that we're going to calculate and their average scores. Okay, so that to me sounds like a 2-sample t-test. They're not paired. By the way, anytime you see chi-square, throw that one out. We are not studying that. We know it's not that. And I'm assuming scores are such as, 97 or 56. So we can actually calculate a mean value. So we're not doing proportions. So we are doing a 2-sample, we don't know population standard deviation, so it has to be a 2-sample t-test. Okay, I know I went through this really quickly, so hopefully that all works out. Let me know if I missed. Well, we're all taking our work at home. So if you're one of those people that does believe you work better with music, then keep calm and listen to Bach. That was the problem with the classical music. If you work better with the hard rock and roll or hip hop, play that. But if you like no distractions, then I suggest you don't listen to anything at all. So once again, you choose the way you think you can best do this, and good luck, everyone. You can get through chapter 11 and you can pass this class.